Welcome to GER Hub. In today's lesson, we shall be looking at STA 104 Statistical Computing 1, and we shall be considering the lesson Mathematical Routines in Microsoft Excel. Previously, in my last video, we considered statistical routines in Microsoft Excel. Please take note that these are just some routines, not all routines in Microsoft Excel, both for statistical or mathematical routines. Please, we are only considering some we want you to know and probably would expose you to others you could find out yourself. It is as easy as that. We shall be considering the lesson objective as follows: to introduce the students to some basic mathematical routines in Microsoft Excel. If you haven't subscribed to this channel, please click the subscription button below. Our analytics shows us that more than 50% of the persons watching our videos have not subscribed to GER Hub. Please do us a great deal of favor to subscribe to the channel now and endeavor to smash a like on this video. You could also share the video and drop your good comment in the comment section. Thank you very much. Now let's begin. So the lesson content for today's lesson will be to obtain the absolute value of a number, how to do that in Microsoft Excel, to transpose a matrix in Microsoft Excel, to add matrices in Microsoft Excel, subtract matrices in Microsoft Excel, perform scalar multiplication of matrices in Microsoft Excel, to perform matrix multiplication, to obtain the determinant of a matrix, to obtain the inverse of a matrix, to solve system of simultaneous linear equations, and to obtain the sine, cosine, tangent, and etc. of angles, and also the sine, the cos, and the tan, or the dan of angle. So please let us look at the following routines. These are just some routines. Please take note in Microsoft Excel that you could consider mathematical. There are other routines I would want you to practice thereafter. So please, let's start with the following. So let's start with obtaining the absolute value of a number. How do we perform this routine in Microsoft Excel? Quickly, um, that's my Microsoft Excel already launched. So all you have to do is follow the steps. It is as simple as put all the routines in step. So step one says launch Microsoft Excel. Step two says impute the value, whose absolute value you want. Step three says choose a cell for your result. Step four, in the chosen cell, impute the formula ABS equal to ABS, which stands for absolute in bracket value or cell reference. Step five says use the command enter to obtain the desired result. So let's look at that quickly. So what I'm going to do, I'm going to show you here is this. So let's assume you want to find the absolute value of any number. Please take note. Now, after launching your Microsoft Excel spreadsheet, please take note of one thing. You need to know what absolute value of a number is. The absolute value of a number, say x, any number at all, will return a positive value. So the absolute value of a number is always positive or zero. What that means is that if you put in a negative value into the absolute value operation, it returns a positive for that value. Okay, so minus 5 should produce 5 in absolute value, 0 should produce 0 in absolute value, and 5, being a positive number, should also produce its absolute value as 5. So how do we get that done in Excel? All I'm going to do is impute the formula. Let's do it this way. So I'm going to start with putting a number, say minus 5. Okay. If you have a number, say minus 5 in Microsoft Excel, and you want to obtain the absolute value, all you have to do is put ABS in bracket. We could go with putting a number minus 5. Okay, let's do that first of all and enter. It gives us the absolute value of minus 5 as 5. So remember, the absolute value of a number is always positive. So what if I chose not to do this using the number itself? You could also put there equal to ABS, that's the command, and then put the cell reference, which is in this case A1. It will still give you, when you press enter, it will still give you 5. Now, what about the absolute value of 0? The absolute value of 0, guys, will give you 0. So you could do this to get the absolute value of 0. It will give you 0. The absolute value of 0 is 0. You could also use the same technique we used earlier on, using the cell reference, this time around A2, and it will give you, when you press enter, 0. Now, the absolute value of a positive number returns a positive number. So let's try the absolute value of 5 as a positive number. It will give us 5. It will return 5. So equal to ABS in bracket 5, which is that. So you would get the absolute value of 5 as 5 if you use the number itself. What if we chose to use the cell reference? I would have 5 here, okay? Cell reference in terms of A3, and that would give us 5. So the simple way to get the absolute value of a number is just to put in that command equal to ABS, or the formula rather, equal to ABS in bracket the cell reference or the number itself, and press enter. It will give you the absolute value of that number. Remember, guys, the absolute value of a number is always positive. Whether for zero, a positive number, a negative number, it will return that same number in a positive manner, or it will return it as zero if it is zero you put in. So that being said, let's go to the next routine I want us to consider in this lecture. This routine is to obtain the transpose of a matrix. How do you obtain the transpose of a matrix? How do you obtain the transpose of a matrix? So let's see. To obtain the transpose of a matrix, all you have to do in Excel, to obtain the transpose of a matrix in Microsoft Excel, step 1 says launch open Microsoft Excel. Step 2 says impute the matrix whose transpose we want. And in step 3, choose a set of cells or area corresponding to the order of the transpose matrix. In step 4, impute the formula transpose in bracket array in that chosen area. And step 5, enter the command Control plus Shift plus Enter. Now, I'm going to show you how that is done. It's as simple as that. Now, looking at these results we've obtained here, let's use this result. Now, these in matrices, what is called the transpose of a matrix is simply a new matrix whose order is the interchange form of the previous matrix. So, for example, take note, the order of a matrix simply tells the number of rows by columns in that matrix. For instance, this one I have highlighted here is a 3 by 3 matrix. This is a 3 by 3 matrix. So let's make it a 4 by 3, a 3 by 4 matrix. So I'm going to add these. Okay. So I've made it a 4 by, a 3 by 4 matrix. Why is it 3 by 4, guys? There are 3 rows, row 1, row 2, and row 3 in this matrix. And there are 4 columns in this matrix, column 1, column 2, column 3, and column 4. So the order of a matrix is the number of rows in that matrix by the number of columns. So if you have a 3 by 4 matrix as we have it here, what is called the transpose of this matrix is a new matrix you form by interchanging the rows and columns of the previous matrix. So if you transpose a 3 by 4 matrix, your result should give you a 4 by 3 matrix. So what I'm going to do to get the transpose of this matrix is to highlight a 4 by 3 space. Since the matrix we want to transpose has order 3 by 4, I'm going to take a separate area in my Excel spread, precisely a 4 by 3 area, which is this one. So this is 4 by 3, let's see. So row 1, row 2, row 3, row 4. These are 4 rows now and 3 columns, okay? So what I'm going to do is to put equal to and put the formula transpose. And I'll put there the cell reference in this case will be A1 to D3. And I'll put Control Shift Enter. So that transposes the matrix. Okay? Remember, the transpose of a matrix is the new matrix you form by interchanging the rows and columns of the previous matrix. Okay? So that is what we have done. You go over it again. It is as simple as that. Now, let's move over to the next routine. The next routine is adding matrices. How do we add matrices? Step 1 says launch or open Microsoft Excel. Step 2 says impute 2 conformable matrices. I'm going to explain that. Step 3 says choose an area of your spread having the order of the matrix addition result. Step 4 says in the chosen area impute impute the formula array 1 plus array 2. Please, array 1 and array 2 refers to the matrices that are conformable for addition. Step 3 or step 5 rather says use the command Control plus Shift plus Enter. Okay, So this is what we are going to do now. Now I'm going to use this matrix we've already gotten. I'm going to use this as my new matrix. Okay. Now let's say we want to add this matrix to another matrix that's conformable. Now please take note, guys. Adding two matrices, what we mean by conformable? Conformable means that any two matrices can be added if they are of the same order. You cannot add a matrix of one order to a matrix of another order. Okay, so they have to be of the same order. Now, what you have to do here is to add this matrix to another matrix of the same order. Now, look at it this way. This matrix we obtained in transpose was a 4 by 3 matrix. So I'm going to put here another 4 by 3 matrix. Okay, let's put another 4 by 3 matrix we want to add to this matrix we got earlier on. So I'm going to put here 3, 4, 2, 1, 2, 4, 3. Okay, 1, 0, 8, 7, 2, and 3. So I have just developed a new matrix. Okay, so I've developed a new matrix. Now, when you add a 4 by 3 matrix to a 4 by 3 matrix, your result should also be 4 by 3. So what you are going to do, once you have created two matrices you want to add that are conformable, remember conformable means they must be of the same order. Now, you will take a sheet or an area rather, you will take an area in your Excel space that is also 4 by 3 because you know that when you add two matrices that are 4 by 3, to each other, the result will be 4 by 3. So I'm going to take an area, a 4 by 3 area in my Excel spread, and then input the formula. Once I highlight that area, I'll input the formula equal to array 1 plus array 2. So what is array 1? Array 1 is clearly F1 to H4, and array 2 is J1 to L4. So I'm going to put here in bracket array 1. In this case, array 1 is F1. Okay. Now, remember, what shows that you're doing the correct thing is that as soon as you start putting the cell reference, that area will be highlighted. So, F1 to H4 is the first matrix. Okay, you can see what I've done. And I'm going to put there plus. And I'm going to put the next array. The next array is J1. Okay, J1 to L4. Okay, so you can see J1 to L4, and I'm going to hold down Control, Shift, and Enter. So that gives me my result. Now you can confirm that 5 minus 5 plus 3 will give you minus 2. 0 plus 4 will give you 4. Okay, 5 plus 3 will give you 8. 5 plus 1 will give you 6. 0 plus 2 will give you 2. 5 plus 4 will give you 9. So that shows you that your result is correct. And Excel can actually do that for you with ease. Okay? So let's move over to the next routine. What if we wanted to subtract those two matrices, one from another? How do we go about it? Now, the same rule that applies to addition of matrices is what applies to subtraction of matrices. So let's put the result we get for subtraction here. Remember, two matrices are conformable for addition or subtraction if they are of the same order. Now, let's perform an operation, a subtraction operation on the two matrices. So I'm going to select an area that is 4 by 3, an area corresponding to the order of the result. And I'm going to put there equal to, the array again was F1 to H4. That was the first matrix. This time I'm going to put minus in bracket. The next matrix was J1 to L4. Okay, J1 to L4. And I'm going to press Control Shift Enter. And it gives me my result. So it's as simple as that for the subtraction of both matrices. You can confirm the result. Okay, so subtracting the second matrix, this matrix from this one will give you this, and adding this matrix to this matrix will give you this result. So let's move over to the next Let's move over to the next routine. So the next routine is on scalar multiplication of matrices. Now the question is, how do you multiply a matrix by a scalar, guys? To multiply a matrix by a scalar involves using that scalar to multiply every element in the matrix. So how do you perform the routine? The routine says launch Microsoft Excel, impute the matrix you want to multiply by a specific scalar, say K, choose an area of your spreadsheet having the order of the matrix that is being multiplied, that is multiplied by the scalar, or and then in step 4, in the chosen area, impute the formula K, in this case the scalar, times the array. Okay? And then in step 5, use the command control shift enter. So let's perform that routine. Let's perform that routine. So I'm going back to my Excel sheet. Now let's assume that this result we had for subtracting the second matrix from the first matrix. Let's assume that we want to multiply this result by the scalar 2. Okay? So my scalar is 2. This is what I'm going to do. I'm going to come over here. Remember, my result was of order 4 by 3. So I'm going to select a 4 by 3 area. I want to multiply the result, this result. I want to multiply this result by 2. So I'm going to put 2 the scalar, and I'm going to put times or multiplication. Please take multiplication, take note of the fact that multiplication in Excel is asterisk. So I'm going to put 2 equal to 2 asterisk, then put the array. The array in this case will be N6, okay? N6 to P9. N6 to P9, okay? So you can see, I'll close that and I'll press Control Shift Enter. So that gives me my result for the scalar multiplication. Now, please take note, in scalar multiplication, when you multiply a matrix by a scalar, in this case, our scalar was 2, the scalar 2 will be used to multiply every element in the matrix. So what we've just done in Excel is to use 2 to multiply minus 8, minus 4, 2, 4, 4, 4, minus 2, minus 7, minus 3, 1, 3, 3, okay? And you will see that multiplying all these, all the elements in this matrix by 2 is what gives this matrix. That's how simple it is to get scalar multiplication of matrix done in Microsoft Excel. So let's move over to the next routine. Now, that was for multiplying a matrix by a scalar. What if we want to multiply 2 matrices? Okay. Now, the rule for multiplying 2 matrices, guys, is simple. Please take note. If 2 matrices must be conformable for multiplication, it is different from when they are conformable for addition. Okay, addition or subtraction. Now, for 2 matrices to be conformable for multiplication means that the number of columns, take note, the number of columns in the first matrix must be equal to the number of rows in the second matrix. I repeat myself, the number of columns in the first matrix must be equal to the number of rows in the second matrix for 2 matrices you want to multiply to be conformable. Other than that, they cannot multiply. Okay, so this is what we are going to do. This is what we are going to do. Now, let's go back to the result we had. I'm going to pick any matrix from here. So this matrix we have is, remember, a 3 by 4 matrix because it has 3 rows and 4 columns. Now, what I'm going to do is this. I'm going to, this matrix, on the other hand, is also 3. This matrix we have here, sorry, is a 4 by 3 matrix. Okay, this is a 4 by 3 matrix. This is a 3. This is a 4 by 3 matrix also. Now, what I want to do to show you how to multiply matrices is to use 2 matrices that are conformable. Clearly, remember the rule. The rule says that the number of columns in the first matrix must be equal to the number of rows in the second matrix. Now, if you look at that rule critically, you will notice that this matrix I have just highlighted can multiply this matrix. Why? The reason is simple. It is because in this matrix we have 3 rows and 4 columns. Okay, take note of 4 columns. In this other matrix, we have 4 rows and 3 columns. So these 2 matrices can multiply. So let's put the result here. Now, another thing I have to tell you is this. You must know in Excel what the result of your multiplication would give. What will be the order of your result? If you multiply a 3 by 4 matrix by a 4 by 3 matrix, the result should give you a 3 by 3 matrix. Okay? So if you multiply a 3 by 4 matrix with a 4 by 3 matrix. Remember, there is the condition for multiplying both of them is that the number of columns in the first matrix, 4 in this case, was equal to the number of rows in the second matrix, 4 in this case. Now, when you take out those two 4s that make them conformable, the remaining numbers are 3 and 3. It means that the result you'll be expecting from multiplying a 3 by 4 matrix by a 4 by 3 matrix will be a 3 by 3 matrix. So what I'm going to do with that knowledge is highlight a 3 by 3 area like I have just done. So in that area I have highlighted, I'm going to put M mult. Okay, M mult is the formula that helps you multiply two matrices. So I'm going to put M mult and put A1, the first array, A1 to D3. A1 to D3. Okay, now A1 to D3 gives me that matrix there. Let's see. So okay, so I'm going to put, let me go over this again. Okay, good. Now the second array will be F. So this was 3 by 4 and the other one is 4 by 3. Okay, good. So I'm going to put F1 to H4. Good. So and then Control Shift Enter. So the reason why this matrix could multiply to give this result you are seeing, clearly you notice that my result is a 3 by 3 matrix. 1, 2, 3, 3 rows, and how many columns? 1, 2, 3, 3 columns. Now, why is that so again? The matrix we multiply had 3 rows, 1, 2, 3, and we multiply it by a matrix that had 1, 2, 3, 4 rows. Okay, so this matrix here was a 3 by 4 matrix multiplying a 4 by 3 matrix. Okay, so they could actually multiply because it met that condition, and the result we got was this. So please take note of the command. You can see the command here. M mult equal to M mult, the first array command the second array, that is the two matrices. So that's how simple it is to get two matrices to multiply, provided they are conformable. Now let's go over to obtaining the determinant of a matrix. How do you obtain the determinant of a matrix, guys? To obtain the determinant of a matrix, just follow the steps. Launch Microsoft Excel, open Microsoft Excel, whichever one. Step 2, impute the square matrix. Determinants apply to square matrices. What is a square matrix, guys? A square matrix is a matrix that has equal number of rows and columns. Okay, so if you have a matrix that has 3 rows, 3 columns, it is a square matrix. 2 rows, 2 columns, it is a square matrix. 4 rows, 4 columns, it is a square matrix. But 4 rows, 3 columns is not a square matrix. So for a matrix to be a square matrix, the number of rows must be equal to the number of columns. Now, once you impute a square matrix, you now choose an area. Okay, you choose a cell rather, because the determinant of a matrix will give you a single value. So you choose a cell in the spreadsheet area to hold the determinant. Then in step 4, you impute the formula MD10. MD10 is the formula that tells you that you want to get the determinant of an array that is a matrix. And you now use the command Control Shift Enter. So let's quickly do that in the Excel area. Now let's assume this is our 3 by 3 matrix. Okay, so let's assume I want to get the determinant of this matrix. All I would do is just choose a cell and put there the formula MD10. Okay, MD10 is the formula that produces the determinant. So what is the cell reference for this 3 by 3 matrix? What is the cell reference for this 3 by 3 matrix? So the cell reference is C6. Yes, C6 to E8. That's the cell reference. So I'm going to hold down Control Shift Enter, and it tells me that the determinant of that matrix is 125,000. Okay, that's the determinant of that matrix. You could compute manually and also confirm your result. Now, so that's how simple it is to get the determinant of a matrix. So you can go over that again in this video. Now let's go to obtaining the inverse of a matrix. The inverse of a matrix is applicable to square matrices also. So what if I want to get the inverse of this matrix? Okay, In other words, A raised to power minus 1, the matrix raised to power minus 1. That's how we denote the inverse of a matrix A. Now, if you want to get the inverse of a matrix, launch Excel, input the square matrix, whose inverse you want, choose an area of the spreadsheet having the order of the result of the matrix. In the chosen area, input the formula M inverse in brackets. You put the matrix or the array. So let me correct this. This should be M inverse, okay? Matrix inverse. Then you use the command Control plus Shift plus Enter. So let's go over to the Excel area. This is a 3 by 3 matrix we already have. So without any waste of time, let's use this matrix. So I'm going to quickly, the inverse of a matrix is a matrix, but the determinant of a matrix is a value. So please take note of that. Now I'm going to put my result here for the inverse, and I'll put here equal to M matrix inverse. Okay. Okay. Matrix inverse. So I'll put the array. My array is C6 to E8. E8. Good. And I will use the command Control, press down, Shift, press down, and Enter. So that is the inverse of the matrix this. So this matrix has its inverse as this. So it's that simple. Remember, the inverse of a matrix is applicable to square matrices, and the formula in Excel is equal to M inverse, and you put in the matrix. So let's now go over to the next thing. Now, the idea of inverse of a matrix can help you a lot. It can help you do it can help you solve a system of simultaneous linear equations. So let's assume we want to solve a system of simultaneous linear equations such as the one I am showing you on my screen. Now, the first thing you must do if you want to get this particular problem solved in Excel is to put this particular system. This is the system of simultaneous linear equations. So there are 3 linear equations put together to be solved simultaneously. So how to solve it is, first of all, put it in matrix form. Now notice that I have done that already. In matrix form, you would have 3 sets of matrices, 2 to your left-hand side and 1 to your right-hand side, in which case the first one to your extreme left is the matrix called the matrix of coefficients. The second one to your left, the left of equal to, is called the matrix of variables. And the third one, which is to the right of your equal to, is called the matrix of constants. Okay? So excuse me. So what I'm going to do quickly to get the inverse of this matrix is this. Take note. In matrix form, this, if I label this matrix as A and this other one as X and this one as B, it will end up giving me AX times AX. A times X is equal to B. Meaning that if I want to obtain X, all I have to do is to say, make X the subject of formula in such a way that A, the matrix A, the inverse of the matrix A, pre-multiplies the matrix of constants B, as you can see here. So the problem of solving this system of simultaneous equation leads to solving this problem. X equals A inverse times B. So what I'm going to do is I'm going to take out this matrix 2, 3, 5, 3, 1, 2, 1, 4, 1. So I'm going to take it, I'm going to put it over here. 2, 3, 5, 3, I think we had 3, 1, 2, and 1, 4, 1. So let's cross check to see. Good. So 2, 3, 5, 3, 1, 2, 1, 4, 1. So I'm going to, this is my matrix A, I'm going to obtain the inverse just like we did. So the inverse of this matrix should also be a 3 by 3 matrix. So I'm going to put the inverse here in a 3 by 3 space. I'm going to put M inverse, okay? And I'll put the array. The array in this case is A, is MC10, so E12. Good. So Control Shift Enter. That gives me the inverse. I have obtained the inverse. Now, beside this inverse, I'm going to put I'm going to put my B matrix. Remember, the problem we want to solve is X equals A inverse and B. And we have just obtained the A inverse in Excel. So what am I going to do? I'm going to bring 2, 3, 4, B, the matrix of constant. I'm going to bring it here, 2, 3, 4, just like we have it here. Okay? So we now have these two matrices. Now, I'm going to multiply this matrix, this, with this matrix. Clearly, both of them can multiply. Why would they multiply? They are conformable. Why are they conformable, guys? It is because this matrix is of order 3 by 3. It means it has 3 columns. And this matrix is of order 3 by 1. It means it has, what do you call it, 3 rows and 1 column. Remember, for matrix multiplication, the number of columns in the first matrix must be equal to the number of rows in the second matrix. So, what result are we expecting? We are expecting, if you multiply a 3 by 3 matrix, that's a matrix that has 3 rows, 3 columns, by another matrix, which is a 3 by 1 matrix, a matrix that has 3 rows, 1 column, the result will give you a 3 by 1 matrix. So it means I'm expecting a 3 by 1 matrix, the first and the last. So I'm going to put there equal to matrix multiplication M more, and I'll put the array of this determinant, the array of this inverse, rather, which is G10 to H12. So I'm going to put here G10 to H12. Okay? Okay, that should have been G10 to I12. To I12. Good. That's the correct matrix. Then I'm going to put a comma there and then go over to this next matrix I want to multiply it with, the conformable matrix of order 3 by 1. So this matrix is clearly having a cell reference K10 to K12. K10 to K12. Good. So I'm going to press Control Shift Enter. And that solves the problem. It means this problem has been solved. So we now have our X1 value. Our X1 value is 1.07895. Our X2 value is 0.86842. And our X3 value is minus 0.55263. So go over it again and you will see how simple the routine was. Okay, now let's go to the next problem. The next problem is to obtain sine, cosine, that is trigonometric ratios of angles using Microsoft Excel. This is very simple in Microsoft Excel. Okay, so all you have to do is take any angle you want and input the formula. So in step 1, open Microsoft Excel. In step 2, what do you call it? You could input the angle, whose sine, cosine, tangent, cotangent, cosecant, secant you want, whichever one. So I will leave the rest to you to explore. And in step 3, just choose a cell. In step 4, input the formula, sine of an angle, cosine of an angle, tangent of an angle, and then in step 5, just press enter. So you can also do that for hyperbolic ratios, okay? So what I'm going to do here is I'm going to come over and put here, let's assume we want the sine of 30, sine 30, okay? So I'm going to put here equal to sine 30. So SIN is for sine, okay? And then enter. So what if you want sine 60? Sine 60, I could just put equal to sine 60 and enter. Okay, so let's go over it again. Now, if I put sine, I could put there sine 30 and enter, and I can do the same for sine 60 and enter. Okay. Now, you may choose to use cell references. Let's assume I have 60 here, and I want to find its sine. I could just put equal sine. I put that cell reference. That cell reference should be G15. G15 and enter. It will give me the same result as sine 60. I could put here 30 and then come over and thereafter put equal to sine 30. Okay, or put the cell reference. Let's use the cell reference G 16 and enter. Give me the same result. So I think Excel is giving you your answer in radians. So you could do that also for cosine of an angle. What if you want to find the cosine of an angle? Just put cos, okay, and then put in the angle, use cosine you want, and enter. It's as simple as that. I could do that for tangent. I'll put tan 60, enter. So you could do that. It's a simple routine, either using the cell reference or the value you want. Now, what if do you want to do that for hyperbolic ratios such as sine, cos, tan, etc.? You could do that for those hyperbolic ratios. Okay, so simply by going to Excel and putting equal to tan, okay, tan 60, and then enter. Okay, I could do that for sine, SINH, sine 60, and enter. I could do that for cos 60, cos 60, and enter. So it's as simple as that for any trigonometric or hyperbolic ratio you want. So that brings me to the end of this lesson. In our next lesson, we shall be considering plotting graphs in Microsoft Excel. So please smash a like on this video and endeavor to subscribe to the channel if you haven't subscribed to the channel to help this channel grow. Until some other time, thank you very much. I'll be seeing you in my next lesson. Do watch out for that video, and please go over my video on statistical routines in Microsoft Excel. Thank you very much.